Good evening everyone. Welcome to the YouTube channel Just Information. I hope you all are fine. Today we will learn Class 7th Science Chapter Electricity Part 2. In this part we will learn conductors and insulators. First, conductors. Electrons coming out of the influence of an atom are called free electrons. Atoms of some substances hold electrons less tightly and so they can be freed easily. Such substances have more free electrons in them, resulting in more amount of current in them. So these substances are called good conductors or simply conductors. Examples are platinum, gold and silver are examples of the very best conductors of electricity. Copper and aluminium are also excellent conductors of electricity and much less expensive. Now, insulators. Atoms of same substances hold electrons tightly and so they cannot be freed easily. Such substances have less free electrons in them, resulting in less amount of current in them. So these substances are called bad conductors or insulators. Common conductors and insulators. Example of conductors are silver, steel, copper, lead, aluminium, impure water, gold, human body, iron, animals, brass, living plants, tin. Insulators example are plastic, glass, nylon, ebonite, bakelite, cotton, wood, flax, cork, pure water, rubber, leather, polythene, alcohol. Now we will learn about uses of conductors and insulators. Electrical wires are usually made of copper. Though silver is a better conductor, it is not used because it is too expensive. Aluminium is also used to make wires. Switches, terminals, plugs, filaments and so on are made of various metals. Insulators play an important role in electrical circuits and equipment. For example, in switches and insulating material, plastic or bakelite separates the metal terminal from each other. The electric wires used in most circuits are insulated either by a plastic or rubber cover or by a coat of insulating enamel. The insulation of wires ensures that an alternative circuit is not created in case of wires touch it, prevents a short circuit. A short circuit between wires can cause a large current to flow, which may even cause a fire. Thus, the insulation of wires protects us from electric shocks. The tools used by electricians such as line testers, screwdrivers and pliers have insulated handles to protect them from electric shocks. Now, voltage. Water needs some pressure to force it through a pipe. In the same way, for electrons to move, they need a push force. This push or force needed to move electrons is called voltage. The voltage is measured in volts. volts, measured in volts. Next is current. Current is the measure of the flow of number of electrons as per second through a material. It is measured by amperes. Current is measured by amperes. After that, power. Power is a measure of the amount of work an electric current can do in a specified period of time. It is measured in watts. Power. Watts. After that, for any electrical device, the higher its power rating in watts, the greater is its consumption of electrical energy. For example, consider a 100-watt incandescent light bulb. The 100 watt does not represent how much light it produces, but how much electrical power it uses. A 17-watt fluorescent lamp may produce much or more, even more light while using only 17% of the power. Now, we will learn about dynamics of shocks. That is, the human body is a good conductor of electricity. The minimum push that is needed for electrons to move into human body is 40 volts. 40 volts. Thus, for human body to feel a shock, the voltage should be at least 40 volts. Therefore, any amount of high current below 40 volts will not cause shock. Similarly, the minimum current that is needed to cause shock is 1/100 ampere. Therefore, any amount of voltage producing less than 1/100 amperes current will not cause shock. For household electrical supply, the voltage needed is 220 volts, which is dangerous. There is a caution for us. Warn students never to conduct any experiment using main supply. Any experiment related to electricity should be performed only in the presence of a teacher. Now, biological damage. Shock is a condition in which the circulatory system is unable to provide adequate circulation to the vital body organs such as brain, heart, and lungs. As a result of a decrease in the blood pressure, the effect of electric shock depends on the following factors: voltage, duration of current, strength of current, frequency, etc. First, voltage. Second is duration of currents. Third is strength of current. This is biological damage. Biological damage. And the fourth one is frequency, etc. Effects of shock. First effect is internal burns due to the large energy available from the source. Second, decrease in the volume of blood pumped from the heart and the blood flow to the brain. Damage to heart muscles. Now, just a little current can kill. Milliamps. First milliamp. One can just feel it. 5 or 10 can't go with it, can't let go. 20, 30, 40, 50. 20, 30, 40 or 50 possibly fatal. After that the 60 to 60, 70, 80, 90, 100, 800, 8000 is like probably fatal. Now electric circuit. An electric current can flow only when there is a closed path for it to travel along. The path along which an electric current can flow is called an electric circuit. The path along which an electric current can flow is called an electric circuit. This is not correct. It is circuit. An electric circuit may be closed or open. There will be a short video uploaded in which the working of an electric bulb and the electric circuit will be shown. A full diagram or a structure of electric current will be there in that video. Now, let us do an experiment to understand closed and open circuits. Experiment. We know that the dry cell has two terminals. The central terminal of the dry cell is called positive terminal. The base of the dry cell, which is made of metal, is called negative terminal. Now, symbols for dry cells. The long line represents the positive terminal. First, the symbol is symbol for dry cells. Negative, positive. The long line which represents positive terminal of the cell. This is the positive terminal of the cell. and the small and thick line represents negative terminal of the cell. Now what is the procedure? Cut the plastic coated copper wire into two halves A and B. Remove plastic coating from each end of the wire such that 1 centimeter of plastic is removed. Now fix one bare end of each wire A and B to the terminals of 1.5 volts bulb with the sellotape. Fix the other end of wire A to the base of cell with the help of sellotape. Now touch the bare end of wire B to the central terminal of cell. Now close the circuit and bulb glows. The diagram of closed circuit is this is a battery. This is a battery. Here there is a bulb. Here is a bulb. The wires connected to the bulb. First, there are the positive and negative terminals. This is the positive, this is negative, or any you can take. This is the wire connected to bulb. The next wire. Now what do you observe? The light glows. After doing this procedure, the light glows. The main is we have to connect the wires from the positive terminal to the bulb and from the negative terminal to the bulb, and on this switch the bulb glows automatically after the switch is on because the current flows from it. The bulb lights up. This shows that electric current is flowing in wire A and B through the bulb. When the path which starts from one terminal of the cell ends at another terminal of the cell without any break, then such a circuit is called complete circuit or closed circuit. When the circuit is closed, then any electric appliance in that circuit starts working. Now remove the wire B from the central terminal. After that, we will see that circuit is broken. After removing the wire from the central terminal. Open circuit and bulb doesn't glow. Now, what do you observe? You observe that the bulb does not glow. It is because electric current does not flow. If the path is broken or path is incomplete, when the path of current starting from one terminal of the cell to another terminal of the cell is broken or incomplete, then such a circuit is called open circuit or incomplete circuit. For example, when we remove wire B from central terminal of cell, then the current is open circuit or it is an incomplete circuit. Switches are used in household wiring to open or close the electric circuit. When we switch on the particular electric appliance, we close the electric current. Conversely, when we switch off an electric appliance, we open the electric circuit. Now, I hope you have understand everything which we have learned in this video, part 2 of chapter electricity. Thank you for watching. In next video, in part 3 of this chapter, we will learn what is switch, electric components and their symbols, and electric fuses. About electric cells also we can learn if there is time. Thank you for watching today's video. I hope you have understand everything. For any queries and doubt, please join the Telegram link given in the description of this video. Thank you.